All right, kids. This lesson is going to be on the quadrilateral unit, but the proofs are going to be Euclidean proofs. That means they're going to be statements, reasons. So the way this video is going to work is you're either going to be proving something is a parallelogram, rectangle, rhombus, or square, or you're going to be given that it's a parallelogram, rectangle, rhombus, or square, and proving things from that, all right? Now, within these proofs, you're going to have triangles. So I'm just going to do a few examples in this video, and we'll be doing the bulk of the work in class. But at least you'll have an introduction so you'll know what's going on, okay? Example 1. Given. Okay, let me give the picture first. Okay, we'll just call this parallelogram GHIJ. Given parallelogram GHIJ. So let me stop right there. By knowing it's a parallelogram, you're going to have all the properties of the parallelogram. Okay, then you're going to be given these perpendiculars. So we'll call this GM and IN. GM is perpendicular to JI. IN is perpendicular to GH. Now, there's many things we could prove. Okay, so I'm going to ask you to prove that GNIM is a rectangle. Okay, here we go. Statements, reasons. So number 1, you put the givens, right? Parallelogram, GHIJ, GM, perpendicular, JI, IN, perpendicular, GH. And you can always embed the givens throughout the proof if you want. So by knowing this, all right, we need to think about what we want to prove. So we're going to want to prove that GNIM is a parallelogram. So my focus goes on these sides. And it also goes on the triangles on the outside. Now, there's many ways to do this proof. So I'm going to start by using perpendicular. And so I have these angles. I'll call this 1, 2, 3, 4. So I'm going to say angle 1, 2, 3, 4 are right angles. And the reason for that is that perpendicular lines form right angles. So my goal in my mind, what I'm thinking to myself is, okay, if I prove GNIM is a parallelogram, then from there, I'll be able to prove it's a rectangle, right? Proofs come in a certain sequence. All right, so what I'm going to do is I'm going to use the fact that GHIJ is a parallelogram. And because of that, I'll be able to say GH is congruent to IJ. I'm also going to say that GJ is congruent to IH. And that is because in a parallelogram, opposite sides are congruent. So you mark that in the picture. This is a little difficult to mark, these sides. Okay, so then I'm thinking to myself, well, why don't I get angle H and angle G, because then I'll be able to prove those triangles. Triangles are often a good intermediary step when you're doing parallelogram proofs. So I'm going to say angle J is congruent to angle H, because in a parallelogram, opposite angles are congruent. So you can see what a powerful statement it is to know that that you have these angles, right? Parallelogram is a very powerful statement. So now I can say that angle 1 is congruent to angle 2, and that's because all right angles are congruent. So now I have enough information to prove that triangle JMG is congruent to triangle HNI. And my justification would be angle, angle, side. Okay, so now here's what I'm going to do. I'm going to say JM is congruent to NH, or HN. I should do it in corresponding order. And I'm also going to say GM is congruent to IN. You guys, this is something you're going to remember when you're old and gray. CSSTP. Ha! Very funny, right? That's because we did the similarity unit. CPCTC. Corresponding parts of congruent triangles are congruent. Okay, kids, now I can do the subtraction property. So I can say that GH minus HN is congruent to JI minus JM, semicolon. So I get GN is congruent to IM. So that reason would be subtraction property. So now I have enough information to prove that GNIM is a parallelogram. And the reason for that is that I have a quadrilateral with both pairs of opposite sides congruent. That means I have a parallelogram. And finally, kids, I can say GNIM is a rectangle. And the reason it is a rectangle is because a parallelogram with one right angle is a rectangle. Now, there are other pathways to doing this proof, but this is the one I went with here. All right. All right, so I'm going to do one where you're going to be working the other way around, and you're going to be given information, and from this information you're going to prove that you have a parallelogram instead of starting with it. There's so many varieties of these proofs, kids, which does not make it easy. Okay, I have GHIJ, and we'll make them intersect at M. So here I'm going to say that GI, this is the givens, bisects JH at M. And we have that angle IJH is congruent to angle GHJ. Okay, and we're going to prove that we have a parallelogram. So prove that JHIJ, ij is a parallelogram. All right, kids, so we have statements, reasons, right? You put the givens. ji bisects jh at m. Angle I, JH is congruent to angle GHJ. Given. So let me just mark this in the picture. Okay, so for line 2, I'm going to have JI bisecting JH, right? So JH is receiving the action from GI. The thing that's receiving the action here is bisected. So I end up with JM congruent to HM. And again, there's going to be different ways to do this proof. But this is because a segment bisector splits a segment into two congruent segments. So you can see here that you have two pieces of triangles. So let's get a third piece using vertical angles. So let's say angle GMK, angle GMK is congruent to angle IMJ. And that's because vertical angles are congruent. Now we can say that these two triangles, triangle GM, did I say GMK? It should be GMH. So triangle GMH is congruent to triangle IMJ. And that is by angle included side angle, because JM is between the angles IJH and angle IMJ. So it's an included side. So that is angle side angle. All right, so now knowing that these red angles that I marked in red are congruent, that will give me parallel lines. So I'm going to say that GH is parallel to IJ. The reason for that is that I have alternate interior angles congruent, so I have parallel lines. Okay, then kids, what I could do, and there's many ways of doing this proof, but what I'm going to do is I'm now going to say GH is congruent to IJ, and the reason is CPCTC from the triangles. All right, so then what I could do is I can say that GHIJ is a parallelogram. Okay, and the reason for this is that when you have a quadrilateral with one pair of opposite sides, congruent and parallel, it's a parallelogram. This is important to know. This comes up often, because the straight way of doing this is just to get opposite sides congruent, right? Or both pairs of opposite sides parallel. But this is a nice, convenient way to do this proof. So definitely know that. All right. Thanks, kids.